Hello, everybody. Welcome to this webinar training on understanding the valve basics. Let's go on to the topic of the day. So we said we are going to have a foundation course on valves. So if I ask people what is valve, I'm sure engineers like you will come out with explanation like what I've shown here. The valve is a simple mechanical device that regulates, directs, or controls the flow of fluid by opening, closing, or regulating. What are the valve functions? The valves are required for stopping and starting the flow. They are required to control the flow, either the quantity or the pressure, or they are required to control the direction of flow, and so on and so forth. There are a number of functions a valve is put in today's context. Sure, you will all appreciate in a plant total outlay for a project like a refinery or process plant, the valve cost is a small percentage, it will be about 2 to 3% of the total outlay. Whereas in terms of quantity, you will find valves and pipe fittings outnumber any critical equipment. In a way, the valves are considered as a C-class item in a plant, whereas it can become an A-class item when the valve malfunction, fails in service and stall the entire operation, or when the plant commissioning gets delayed because of non-availability of a critical valve, or when the valve performance affects the safety, environmental, health parameters of a plant. It draws the attention of all the people. Hence, valves are essential part of the industrial piping system and are critical for a plant operation. So in this regard, it is important that people dealing with valves day in, day out, either could be a piping engineer or could be an operator or could be a maintenance engineer, it is desired that he should have a good understanding of the valve, which will help them to get the maximum benefit from the valve performance. So the entire objective of this session is to lay a foundation for that, and which you can build on further to become a domain expert on valves. You will all agree that if you want to have a command on any subject, you need to understand the fundamentals very clearly. So that's what we are going to spend few minutes on this, understanding the valve fundamental. Basically, there are two known ways of controlling the flow of liquid or gases. All the valves what you see around you are in the essence based on these two principles. Let's see what are the two principles. Imagine a water tank filled with water, and there is an outlet at the bottom. There are two ways by which you can stop the flow. One by putting your thumb against the orifice, you can stop the flow. Or if the tube is flexible, then you can squeeze it and then stop the flow. These are the two fundamental principles against which all the designs are evolved. The first principle is, again, is developed into three different methods. What you see here, the first principle is different into three different. The way the stopper is presented to the orifice. The simplest method of moving a stopper is moving by direct thrust onto the orifice, like what you see here. And this is the basis of all your globe valves. Imagine if the stopper is rotary, and you can, by rotating movement, you can stop or start the flow. And this is the basis of all your quarter turn valves, ball, butterfly, plug. The third method is to slide the stopper against the orifice. And this is the basis of all your gate valves. And of course, the second principle, which is the squeezing principle, is the basis for all your diaphragm valves. So now let's see how these principles are evolved in making the design for valves. So if you take a globe valve, you will find the closure device, we call it as obturator, is moved in a linear direction in the seating area, and it is parallel to the flow with the longitudinal. Okay, and if you take the quarter turn valves like ball and plug, you will find the closure device rotates about an axis at right angle to the direction of the flow. And in open position, you will find the flow is taking place through the closure member. On the other hand, a butterfly valve, you will find, is again a quarter turn valve. The closure device rotates about an axis at right angle to the direction of flow. But when the flow takes place in open position, the flow goes around the disc. Okay, and when it comes to the sliding gate valves, you will find the disc moves in a linear direction perpendicular to the flow. Okay, and of course, the diaphragm valve is one where the deformation of this diaphragm gives you the tight shut-off. So thus we see 4 different movement of the closure. We were able to develop 5 basic designs. And whatever we see around us can be fitted into this variant. The slide, what you see here, shows how different types of valves are fitted into this 4 fundamental principles. Okay, and this is not an exhaustive list. Basically, from this categorization, we can have 2 categories. One is the linear motion valves are called as multi-turn valves. The other rotary movement valves can be called as a quarter turn valves. So these are 2 broad classifications you will see. Now let's move on to understand what are the characteristics of each and every type of generic valve what you're seeing. The globe valve, what you see here is a globe valve. The advantage of a globe valve is that the direct thrust of the disc onto the seat is seen here. So this feature gives a tight shut-off characteristics for the valve. One can feel the valve is closed and is positive. The internal flow, if you watch, it takes 2 right angle turns. Okay, this 2 right angle turn, you all know it gives a pressure drop, and this pressure drop characteristics helps this valve to be used as a regulating valve. This regulating characteristics is nothing but there is a known relationship between the flow of the movement of the disc and the quantity of flow. And that's why you will find globe valves are more popular as a control valve. And another important aspect is that when it is used in throttling applications or regulating applications, you will find that the flow is taking parallel to the seat area. So there is a even wear and tear. And that's why you will find, unlike other valves, these globe valves are able to sustain as a control valve. Globe valves have got shorter stroke length to open and close. As a thumb rule, you can say 1/4 of the stroke length is required for opening. Okay. The disadvantage of the globe valve is that it cannot be used in an application where the pressure drop is a concern. Now let's move on to the plug. The plug is belongs to the quarter turn category. It is straight flow through, and consequently the pressure drop is less. It is quick action because it requires only 90-degree operation. The other advantage of the plug is that the seating area is protected from the effects of the flow. Hence, it finds a wide application in handling slurry media and all. The disadvantage of plug is difficult to get that tight shut off with the ease of operation. The other disadvantage is that maybe because it is fast acting, it can cause some water hammer effects in certain hydraulic applications. There are 2 types of plug valves. One is lubricated and non-lubricated. Lubricated plug valves use lubricant, and non-lubricated plug valves use soft materials, elastomers, polymeric materials. So this puts limitation on the temperature. So the temperature is limited by these materials. Now let's move on to the ball valve. I would say the development of a plug is a ball. Similar to plug, ball also requires quarter turn movement and is also fast acting. The main advantage of the ball valve is flow is through and through. There is no obstruction and offers the least resistance. And that's why you'll find ball valves are very popular in cross-country pipeline where they need full bore valves. The advantage of a ball over the plug is that ease of operation. If you see the ball plug, you will find that the entire plug is being enveloped in the seat, body seat. Whereas here in a ball, you will find that the ball is in contact with the seat only through a segmental link. So this helps you to give a low torque. In addition, when you use a soft seats like PTFE, which has got a low coefficient of friction, it helps you to reduce the operating torque. So these valves are best suited for tight shut-off. They are suited for throttling applications, limited, and best suited for fast action. The temperature is again limited by your seat material. There are metal seated valves, but then the soft seals used in these will put the limit on the temperature. Then we'll move on to the butterfly valve. Is again a development of a ball valve, I would say. It's quite compact, quick acting, and easy to operate. It is well suited for regulation. Next to the globe valve, I think butterfly valves are very popular in control application. The only disadvantage with the butterfly valve is that disc is always present in the flow passage, hence offer resistance, and the pressure drop is high. So as a thumb rule, you could say that SA size valve, if you take the pressure drop in a butterfly valve ball, 3 times the gate valve. It is also limited in smaller pressures, not high pressures, because for high pressure, the disc thickness will become very massive and your flow area gets obstructed. So the disadvantage is when you use a resilient seat for getting tight shut off, that puts temperature limitation on this. And pressure drop is high due to the presence of the disc. Then we have the most popular valve in the industry, which is the gate valve. Gate valve is a straight flow through when the valve is open and offers the least resistance, least pressure drop. Being a metal seated, there is no soft seat in the ball with the valve, and it can be used for high temperature, high pressure application. That's why you'll find more such valves are used in the process industry, refineries, and where the temperature and pressures are involved. The disadvantage of a gate valve is that it is the slowest acting valve. Why? Because the wedge has to move through the bore to clear the bore to fully open position. So wherever a fast action is required, I think you have to stay away from the gate valve. The second disadvantage is it requires a lot of headroom. And this valve is not suitable for throttling application. It is the best suited as an on-off valve. In throttling application, when it is used at an intermediate position, the disc is subjected to vibration, and then a lot of wear and tear takes place. Hence, it is not recommended for throttling. Then we have this diaphragm valves, where it is also called a glandless valve. There are 2 advantages in this diaphragm valves. One is the diaphragm is flexible and it gives a positive shut-off. That's why it's suited for all slurry or solid metals. All your sewage lines will use this type of valve. Disadvantages, by using diaphragm material, the temperature is limited. So to summarize the 4 basic variant advantages and disadvantages is shown in the slide. I don't want to repeat it. All I want to say is multi-turn valves are quick acting, and except the butterfly valve, rest of the valves like plug and ball, they have least resistance in the quarter turn valve, sorry. In the multi-turn valves, globe and the gate, they require longer time to operate it. And globe valve is best suited for on-off as well as regulating, whereas gate valve is suited only for on-off application, not suitable for regulation. So it is better all understand the differences between these two variant, so that when you see select a valve or use a valve, you will be able to remember these characteristics and apply it in your day-to-day. So now, having seen the basics of the valves, we'll move on to the important topic on valve parameters. See, in order to get a maximum benefit from the valve and in order to get a reliable valve performance throughout its life cycle, we need to select a right type of valve. So to select a right type of valve, I think we need to specify the right type of valve to the manufacturer, matching with the application. So that is where the valve parameters comes in play. Valve parameter is nothing but is really a valve specification that goes to define a valve. Both valve manufacturer as well as the end user should be familiar with these parameters. Let's see what are these parameters. I've listed out essential parameters, 7 essential parameters starting from valve size, type, class rating, and connections. This is not an exhaustive list which goes to define a valve. If you see a valve data sheet, you will see, the design pressure, design temperature, then process flow media, then the noise level if it is there, or the type of packing, all those things. All goes to define valve. But these are essential, and let us see what each one represent. Let's take the valve size. If I ask a layman what valve size, he will say that it is some dimension inside the valve. But when I ask this question to people like you who are familiar with valves, you will all say that valve size is nothing but the pipeline size onto which the valve is going to be mounted. It does nothing to do with your valve dimensions. It doesn't represent any of these things. There are two methods by which the valve size can be represented. So one is the imperial system, the inch system, where countries like US and all are using still. It is represented as NPS, nominal pipe size. And the other system is the metric system, SI system, where dimensions are, length are measured in meters and weights are measured in kg. So here the valve size is mentioned as DN 200 or 250. DN stands for nominal diameter. So NPS2 is equivalent to DN 50 in terms of the representation. Sometimes you will find valves are designated by 2 digits. So what does that mean by? It is nothing but the valve is a reduced bore valve. When you say a valve DN 100 by 80, it means that the ends are suitable for mounting on a 100 mm pipe, whereas the valve is for 80 mm. So similarly in plug valves, you will find the size is suffixed by something called letter called R, which means it is a reduced port valve. When you say a 16-inch R means you can understand that is a reduced port valve. So let's understand what is that valve type. We saw basic type, but classification based on functions is what really required for selecting the valve. Basically, you find valves can be used for isolation. Isolation is a valve designed for use in fully open or fully closed position only. And all these valves, what you see, gate, ball, plug, piston, diaphragm, all meant for isolation. Regulating valve is nothing but a valve designed for use in all position, between open to closed position. So you'll find the globe comes in the top, followed by other valves. Safety relief valve, as the name implies, it is meant for relieving the pressure. It does automatically when the set pressure is reached. Okay, and non-return valve, sometimes it is also called automatic valve, is basically unidirectional valve. It opens in one direction and closes in the other direction. And then, of course, we have the control valve. A control valve is a power operated device which changes the flow rate in a process control system. It contains actuator that is capable of changing the position based on the signal you get from the control system. Okay, and then of course you have other types of valves based on their application, like float valve, foot valve, Okay, this is a classification and one need to be clear what purpose it is required. Then we'll move on to the class rating of the valve, which is a very important aspect. A valve is designed to handle certain range of pressure, and there is a limit for pressure to which it can be subjected. And this is called the pressure rating of the valve. Pressure rating is nothing but pressure carrying capacity of the valve. Normally, pressure carrying capacity is not constant with temperature. It goes down with temperature. That is why you will find the standard ASME 16.34, which is one of the oldest standard, made an attempt to standardization in the valve industry. It gives the pressure rating for different group of materials. So how it is represented, like what you saw in the size, here also, in imperial system, valve is represented by terms like class 150, 300, 600. The class 150 doesn't represent any pressure. It's basically, if you want to look at it, you should look at the pressure temperature chart where it will say at room temperature, 285 is the maximum pressure carrying capacity. As the temperature goes up, the pressure drops because material loses its property. So apart from the imperial system, in the metric system, it is designated as PN10, PN15, PN100. PN is nothing but nominal pressure. There are different class ratings. See, what you saw is a standard class rating, which is listed in the standard. And this is changes with the material groups. Okay. So now there's yet another class called special class rating, where you have a higher temperature to be used. And instead of going for a next class, probably the standard allows you to use a special class with certain conditions, like you have to carry out a ND on the valve body. Okay, so let's see with an example. What you see here in this table, you'll see the top table shows the standard class and the bottom one shows the special class. Example, your process temperature is 800 Fahrenheit and pressure is 500. If you were to select a valve from this standard class, one would select a class 600 valve. Okay, because at 500, only 600 class will be suitable. Whereas if you take a class, special class, you end up with choosing class 300. So that means your valve size is reduced, cost is reduced. Why? Because in the calculation for valve thickness, there is something called casting quality factor. When you do a NDE on the, like a radiography on the valve body, you can use a higher casting quality factor. Thereby, for a given valve thickness, you are allowed to operate at a higher pressure. Okay, so you see a difference here. Class 150 valve standard class is 80 psi, whereas special class will allow up to 195. So let's move on to the next category, is the intermediate rated classes. So similar to that, in the class rating of special and standard, you will have an intermediate. The standard gives an option to use design to intermediate class like 3300. When you find your pressure temperature is in between class 2500 and 4500, if you are forced to select class 4500 because it is not available intermediate, then the option is available for you to engineer a design. Okay, and select a design class intermediate class. You can say class 3300. If you are going to have a pressure temperature in this range, you can call it as a 1800. Only thing is, though this design gives sort of advantages in cost as well as weight, but it requires an engineering effort from the customer point of view. And pressure temperature for soft-seated valves are different than the metal-seated valves. What you see here is a chart for a ball valve. When you operate in this zone, you are safe. When you operate outside this zone, there's going to be degradation of the material. The end connections, I think there are a number of different end connections available for joining the valve to the piping system. The most popular are these. Screwed ends are more popular in small sizes up to 2 inches. And the most popular is the flanges for larger sizes. And then when you want a permanent joint, probably you would go for a welded joint. So there are 2 types of welded joints. One is the socket, which is popular up to smaller sizes, 2 inches, where you have a socket and then the pipe goes onto it and you do the welding. When you're dealing with the larger sizes, you go for a butt weld end. These butt weld ends are permanent joint used widely in high pressure, high temperature applications. where what you do is you have two lips machined on the flange side as well as on the pipe side as well as the valve side, which is butt against each other. And then while doing the end, you have a U groove or V groove, which is filled with the weld metal. So it gives a permanent joint, widely used in certain applications like buried service or high temperature application. There are a number of variants available for flange. It could be a phrase face or it could be a ring type joint gasket. Depending on your service, one would select a material. Then let's move on to body material. Basically, valves are exposed to pressure, temperature, and the corrosion of the line media. Hence, the standards regulate the use of materials for valve constructions. Traditionally, a valve industry is evolved around codes and standards, and the materials are dictated by standards like ASTM, that is the American Society for Testing and Materials. So those specify what type of material you should use for a particular application. So what you see here is a popularly used materials, carbon steel, which is standard is ASTM 216 WCB, and that's got a temperature limit of 425. When you use alloy steel high temperature applications, probably one would go for a creep resistant seals like C12A, where the temperature is 650. So there are a number of materials available. Again, it's listed in standards like ASTM, and then one more standard is the ASME, American Society of Mechanical Engineers, which also designates standard, and both ASTM and ASME will have a same designation. So let's move on to the other parameter, which is a trim. Trim is nothing but a collective term used to denote certain internal surfaces which are wetted and wear prone. Okay, the trim refers only to the surfaces, not to the base material. And where you find all this trim material description, you will find it in the product valve standards. For example, if you take an API 600 gate valve, the standard will say the trim is a trim, the bonnet bush is a trim, the body seat face, the disc seat face are trim. Similarly, a ball valve standard, if you take, it will tell body seat, ball seat are trim material. So basically, the trim is selected based on your service condition. Typically, what you see in this is a trim chart which I have extracted for API 600. That if you go through the standard, it will give a number of trims. So when you say trim 5, what does it mean? The seating surfaces. In the gate valve, the seating surfaces are wedge and the seat ring. So both will be hard faced using sterlite. And what was the application of this? It's basically a premium trim used for high pressure, high temperature, and severe surfaces. So likewise, there are trims like model, which is used for oxygen surface, right? So one has to look at the standard for knowing the trim, allowed trims. And then of course the valve operator, which is the final valve parameter. What do you understand by valve operator? Any device which is used to provide a force or a leverage or mechanical action or torque to open or close the valve or regulate the valve in intermediate position is called operator. So what are the valve operators? You have, it could be either a manual operator or power operator, or it could be an automatic also. Okay. So manual operator, what are the manual operators? Simple devices for small sizes, a hand wheel. For larger size valves, one would go for a gear unit. Why gear unit? Because the gear unit has got certain mechanical advantage which will help you to reduce your effort. If you are going to use a valve at a higher locations, probably you can use a chain wheel to operate it. And then of course, the powered actuators are electric, it could be a pneumatic, or it could be a hydraulic, or it could be a combination of electro-pneumatic. The type of operator selection is decided by the customer, is based on number of factors like valve size. One would like to operate a large size valve using an actuator. No one would like to operate a 72-inch valve using a hand wheel. It will require thousands of revolutions to open it. Okay. Similarly, in certain critical applications like emergency shutdown valves, you need to have a actuation using pneumatic or electro-hydraulic so that it is able to operate it in case of any emergency. So these are the operators, different operators, and why need actuations? I think this cartoon is self-explanatory. As I told you, large size valves, you better to have an operator. electric actuator. If you are going to use the valve in a remote area, it is ideal to actuate it, right? You don't want to send so many people to operate the valve. Or if you have got a hazardous application environment, then probably you would have an actuator. Example, a nuclear industry, in any valve which is used in the contained area, you would not risk sending an operator to operate the valve. It's ideally a power actuator. And sometimes when you want to operate a valve in a sequential manner, then obviously you go for a actuation. Okay, so we come to the final part of the session. We understood the basics of valves, 4 types of movement of the obturator or the closure device. So it could be a sort of a direct obturator movement, or it could be a sliding or rotary. In the rotary, we saw 3 types. Valves are like ball, plug, and butterfly valve. And we also spent some time briefly on this generic types, the advantages and disadvantages. And then we spent some time on the valve parameters. We knew what we understood what is meant by valve size, pressure class rating, the term trim, the connections. Within this short period, what was attempted is to give an exposure and oversight of all this valve basic. It is expected that people who want to become an expert on valves should go further deep into it. Okay. So with this, I conclude my session.